Good morning, guys. Today we are going to move forward from law of sines and cosines, and you just had your test on that. We're going to talk a little bit about area the next few class periods. Now, what happens, just like when we were dealing with, law of cosines, we can only use SAS to solve it. What happens when we're given a triangle with SAS set up, and we're told to find the area of that triangle? Now, normally we all know area is 1/2 base times height. But this is a little different, and it's not necessarily a right triangle. We are not given the height, so what are we going to use? We're going to use something called the SAS area of a triangle. And this just basically tells me, again, there are 3 different formulas like law of cosines, depending on what angle you're using. But say I have a triangle ABC, and I am given, I don't know, I'll just pick... in this case, you have to be given an SAS area setup. So I have to be given 2 sides and the angle in between. So say I'm given side B, side A, and angle C. And how I'm going to plug in is I'll take 1/2 the 2 sides and then times the sine of the angle in between, which in this case would be angle C. Now, if I would instead use angle A, then I would, need side B and I would need side C and so on and so forth, which is why there are just 3 different formulas. It's the same formula, just depending on which sides and angles you're using. Okay, but you need SAS area, SAS setup to use SAS area. So the first example says, find the area of triangle ABC. So do they tell me, so I'm just drawing it, triangle ABC, you can draw it, the B can be up top, it's up to you. Just go in order, don't go jumping around like crazy. They tell me A is 12, C is 9, the measure of angle B is 150. Remember, little a is opposite angle A, so they're telling me side A is 12, side C, opposite angle C, is 9, and that does matter. You need side C opposite angle C. And then the measure of angle B is 150 degrees. Remember, you can only use this if you have SAS set up. So if you don't, most likely, you labeled it incorrectly. So it's a good way to check yourself. In this case, we do. We have SAS set up. So how are we going to use this formula? Very simple. We're finding area. So it's 1/2. So the area, SAS area, is 1/2 my 2 sides, 12 times 9, and then the sine of the angle in between them, which is 150. Make sure you are in degree mode. And you can just plug this in your calculator. 1/2 times 12 times 9. If you did 1/2 times 9 times 12, same thing. So it would be 1/2 times 9 times 12 times the sine of 150. And you will get that your area of this triangle is 27 units squared. And this is actually fairly simple formula. I enjoy teaching it because it's something simple. Law of cosines can be very, very challenging and very long. These tend to be pretty quick problems. Okay? If you go on to the next one, this is actually a you try problem. So I'm not going to work it out, but if you go into your worked out notes, you'll see that I did indeed work it out for you. So it's something you can try and then go check the worked out notes. Make sure you understand what I'm doing. Okay? Our next example. So how else can we use SAS formula? Say for an octagon or some other sort of polygon. This example says, find the area of a regular octagon inscribed inside a circle with a radius of 9. And I give you a picture. Now, if it's an octagon, it has 8 sides, which means it has 8 equal sides and angles. So how am I going to use the SAS formula? Well, I know that if it's an octagon, it has 8 little triangles, right? So it has 8 SAS triangles. How do I know these have SAS setups? Well, they gave me my radius of 9. So if you look at the picture I gave you, you can see that I actually do get 8 identical triangles. My 2 side lengths of those triangles are 9 and 9 because that's the radius. But in order to use SAS, we need an angle. Well, I told you in the problem that it's an octagon. 8 equal sides, 8 equal angles. But that also means if that we're making 8 triangles, 8 equal triangles, there are 360 degrees in a circle, divided by 8, which tells me each one of those inside angles are going to be 45 degrees. So what I actually end up getting is 8 identical SAS triangles. Because the radius is 9, the two sides are 9, and the angle in between is 45 degrees. Okay? So what I'm going to do, remember, I'm not solving for that third side, I'm now finding area. So, for example, just to step back for a second, if this was, I don't know, a decagon that has 10 sides, that means that you would have 10 identical triangles, so you would do 360 divided by 10, to get me each of my angles, my theta, in between would be 36. And if you had 6 sides, it would be 360 divided by 6, and so on and so forth. Okay? So what are we going to do? We know that the full area of this thing means if we find the area of one little triangle, one little slice, we can multiply it by 8 and get the area of the whole thing. So I'm going to use SAS formula to find the area for one piece or one triangle. And what is that? 1/2, the two sides, 9 times 9, the sine of the angle in between, which is 45 degrees. Okay? So what do we get? Well, just plug it in. 1/2 times 9 times 9, or 1/2 times 81, times the sine of 45 gives me 28.64. So this is the area, and I'll shade it in. This is the area of one triangle. How many are there? It's an octagon. There are 8. So I'm going to take my area of one slice times 8, which will be 28.64 times 8. That means my area for my entire octagon is going to be 229.12 inches squared. Give me labels here because it's area, and area is always square. Okay? The important here is that they tell me it is a regular octagon. Regular means all of the sides and angles are the same. If this was not a regular octagon, then we would not know that. If it wasn't a regular hexagon, we couldn't do the same thing. Okay, so look for that word regular. It means that you can follow along just the way I did it. Okay? And basically you're just doing SAS formula and multiplying it by the number of sides. But you need to find the angle in between first. They will give you the radius. Okay? Or the diameter, and you just divide it by 2. And good job so far. Let's move on to our last example. Now this is pretty much the only extra thing I can do with SAS formula to make it harder, which is we want to find the area of this triangle using SAS formula. Now if we were in class, I would ask you guys, what is the problem here? What are we missing? Well, it's SAS formula, and I have 3 sides. I don't know an angle. But let's think. If you look back to the last section, law of cosines, we learned that if we had SSS set up, we could use the law of cosines to find an angle, and then we can use that angle. Then we'll have SAS set up, and we can find the area. So that's what we're going to do. Our first goal is to find an angle. So first we're going to find an angle using law of cosines. Okay? It's really up to you what angle you choose. In my example, worked out example that I'll follow, I just use angle C because, the other two are on the top. You could have found angle A, you could have found angle B. That will change the work at the end though, which I'll talk about. But if I'm going to solve for angle C, using law of cosines, the 13 squared has to be alone on the other side, the side opposite from that. So 13 squared equals, go back to your law of cosines formula, the other two sides squared, minus 2 times 6 times 9, cosine of angle C, which we're solving for. I'm going to clean this up. Okay, I'll subtract over, so 13 squared minus 36 minus 81. I'm going to get 52 equals, negative 2 times 6 times 9 is negative 108, cosine of angle C. Divide by negative 108. Don't be afraid to get a negative here. It's perfectly fine. So what you're really getting is negative 0.48148 equals cosine of angle C. And we talked about this. How do we get the angle out of the cosine? We take inverse cosine. and we'll get angle C. So the measure of angle C is equal to 118.78 degrees. Okay, but remember, this is not an answer. This is just going to help us find the area. So I'm just going to draw my triangle and what I know now. So I have sides 6, 9, 13, and the angle in between, so angle C, is 118.78. Okay? Makes sense? It's the opposite the biggest side, so it's going to be the biggest angle. So now we're going to use SAS area formula, which is 1/2 two sides. So it's SAS, 1/2 two sides and the angle in between. So you cannot use the sides 6 and 13 together. You cannot use 9 and 13. You have to use 6, 9, and the angle in between. It has to follow SAS, okay? This is where if you solve for a different angle, if you solve for the angle in between 6 and 13, you would have to use 6 and 13. If you solve for the angle in between 9 and 13, you would have to use 9 and 13. You will still get the same answer for the area. It's a good way to check yourself. Okay? So again, I used 6 and 9. I have solved for the angle in between them. So those are the sides I need to use. So SAS area, 1/2, 6 times 9, times the sine of the angle in between, which we found to be 118.78. Plug that in your calculator. Your area is about 23.6. And it says on the directions to the nearest 10 square units. So I'm not going to say the nearest 10, but I'll just leave it like that. You can leave it like that. 23.66 units squared. They give you inches or meters or anything, use that. Okay? So far in these notes, we just use SAS formula when I gave you side angle side. We use SAS formula to find an area of a regular polygon, in this case an octagon. And the harder example was we used SAS formula when we were given 3 sides. We use law of cosinus to find one angle, and then we can use SAS. Okay? Good job on these notes. You can go and you can check out your homework for tonight on SAS area. Next section we'll be talking about Heron's formula.